Hello and welcome to our webinar which is presented live every Thursday. The topic we will talk about today is how fire is perceived in hotels. The topics we will talk about in order: the purpose of the webinar, the importance of fire detection in hotel fires and hotels, standard of fire precautions in hotels, perceives, manual call points, audible warning devices, basic components of systems. Purpose of webinar: to provide information about the fire risks in hotels, buildings and the technology used in the early detection of these risks and their use. The success of mentioned industry is directly dependent on the comfort, health and safety criteria of these facilities. Naturally, guests want comfort, health and safety criteria of their buildings to be of the same standard all over the world. Detection possible fires in hotels, motels and holiday villages as soon as possible, making necessary warnings, controls and interventions is one of the indispensable conditions for the life safety of guests. There are many rooms on the floors of the hotel buildings. In case of possible fire in general areas of the hotel, although this situation can be noticed early by the guests or employees in case of fire in the rooms, it is not possible to detect it early when the room is empty or the room guests are asleep. Example: many factors such as heating of electrical appliance, kettle, TV, hair dryer, adapters, carelessly consumed cigarette products, candles can be shown as the cause of fire. Fires in hotels are evaluated in two categories. It has been statistically proven that the fires in the kitchen, boiler room, garbage processing facility, chimneys, energy rooms, and common areas of the hotel constitute 49.8% of the fires in the hotels. With the Standard Fire Precautions Directive of Hotels, Motels and Holiday Villages, which was put into effect by the European Union and has been accepted and implemented in many countries, it has been determined to minimize the risk of fire in hotels, motels and holiday resort buildings and to take measures to ensure the life safety of people in case of possible fire. According to relevant directive, it is said that all volumes of the building designed for accommodation, like bedrooms, corridors, common spaces, auxiliary facilities, training and sport halls, and everywhere else should be equipped with smoke detectors. The fire detection and warning system must be capable of monitoring the follow switches, line shut-off valves, and all control points of the fire extinguishing system installed in building. The fire alarm system should have mechanisms to give sufficient audible and light warnings throughout the facility. The system should have the ability to send messages, SMS, email, at night or when there is no response team. The system must be capable of transmitting messages to local emergency response teams or a reliable telephone or other communication means. TCP/IP, GPRS, etc. After the fire detection is determined by the control panel, audible and visual alarm warnings for evacuation can be delayed for a few minutes. As soon as the necessary response teams see the fire message at the control panel, they go to the address where the alarm is received, confirm the smoke and flame effect of fire, and then evacuation warnings are made. In this way, all guests are not disturbed by false alarms. When guest detection is made in the kitchen, other cooking areas, boiler room, and storage areas related to flammable and combustible gases, gas cutoff should be done automatically at the gas supply points or centrally. When the toxic gas, carbon monoxide, level increases in closed parking lots, Necessary automation should be provided by giving the necessary commands to the ventilation system. In case of fire, there should be those that slow down the flow of smoke in the floor corridors. These doors, which are normally supported by magnetic flow holders, must be controlled by fire alarm system, released and closed in case of fire. All closed escape stairwells and elevator shafts should be equipped with pressurization system in case of fire. Pressurization system should be operational under the control of the fire system in case of fire. Comfort ventilation and smoke exhaust ventilation controls in the building should be made by fire alarm system. In the standard, it is stated that all elevators should be directed to the emergency exit floor by the fire alarm system in case of fire. In addition, fire detection and alarm systems are designed, implemented, and operated in hotels in accordance with the regulation on the protection of buildings from fire, which is valid in many countries, and the EN 5414 standard to which this regulation refers. Basic components of the systems are shown in the figure: buttons, detectors, sounders, and panel. Perceives. We have three effects in case of fire: smoke effect, heat effect, flame effect. As a result of combustion, basic effects such as smoke, heat, and flame occur. Detectors used for fire detection are produced with features that detect one or more of these effects together. Depending on the characteristic of combustible materials in the area, the order of occurrence of the effect of fire may vary. Example: since there will be smoldering in wood or cotton fire, first of all smoke occurs, the temperature increases, and the last flaming occurs. Therefore, it is necessary to determine in advance of the types of substances that can burn in possible fire in the environment and their effects in case of fire. In addition, we can decide on the type of detector to detect the fire by considering factors such as the ceiling height, the effects of the ventilation system, the ambient conditions of the places, and the possibility of false alarms. It is appropriate to use optical smoke detectors in hotel rooms, in general places where there is no humidity and dust. In hotel rooms, the exit hall of bathroom section can generally be exposed to water vapor. Therefore, if a detector is used in this section, false alarms may occur. In this sense, it is ideal for the rooms to be positioned so that the smoke detectors are above the bathroom. The rays coming from the IR LED are not refracted in normal condition in optical smoke detector. However, if there is a fire situation, there will be smoke particles in the detector, which causes the beam to break and fall on the photodiode seen in the figure. In this case, the detector comes to the alarm state. The rays coming from IR LED are not refracted in normal condition. However, if there is a fire situation, there will be smoke particles in the detector, which causes the beam to break and fall on photodiode seen in the figure. In this case, the detector comes to the alarm state. What about optical smoke detector placement? 6.5.2.2 is the standard with smoke detectors. The maximum detection radius for a smoke detector is 6.2 meter. For a square detector array in an open area, the detector should be no more than 8.8 meter apart from each other. They can be up to 4.4 meter from a wall or a large obstacle. The detection principle in normal and fire conditions for beam-type smoke detectors is as follows. Normally, the beam sent from the transmitter reaches the receiver completely. In case of fire, the beam intensity sent from the transmitter reaches the receiver by decreasing. If this decrease is less than or equal to the alarm level set by the user for 6 to 8 seconds, the detector will enter the alarm state. As you see, it goes transmitter to receiver. Beam type smoke detector. EN5414 or 5414 or 15.4 is a regulation about areas with high ceilings. In buildings with high ceilings, it is important that all fire protection measures, including fire compartment, smoke and heat control, fire extinguishing, etc., as well as fire detection and fire alarm system, are coordinated and their interactions are properly controlled. The requirements of this guide should be taken as a starting point only. Additional detection or unusual detector configurations may be required. In the places with high ceilings, the fire load is usually such that there is no need to monitor the entire level. Linear beam detectors should be used. The resulting risk at levels higher than the temporary fire load, example sails and banners, can be considered negligible risk. Linear beam detectors should be mounted at sufficient height, 9 meter to 12 meter recommended. The maximum horizontal distance between two detectors is 25% of the installation height when the detectors are not within the 10% of zone. Additional angle beam detectors may be considered appropriate if the detectors are ceiling mounted and there are concerns about the effect of stratification. Beam type smoke detectors consist one receiver and one transmitter unit. You can place the receiver and transmitter in such a way that they see each other and are within 100 meters of each other. Thus, you can protect an area of approximately 1,500 meters square. The distance between IR beams of the beam type smoke detectors to a wall or an obstacle is minimum 50 centimeters. There are three types of use of temperature detectors, which is heat detectors. One usage is as follows. A reference value is determined. For example, let this value be 60 degrees. When the detector detects that the ambient temperature exceeds 60 degrees, it gives an alarm. It's already shown in the first figure. Another use is related to the increase in temperature. A time and temperature increase that will occur during this period are determined. For example, let's say 30 degrees in 1 minute. If the ambient temperature increases by 30 degrees in 1 minute, the detector will give an alarm. As for use as a combined temperature detector, this is called the case of doing both at the same time. It has fixed reference temperature. It also monitors temperature rise and time. It will be alarmed when either or both. It's shown in the third figure. 6.5.2.1 is the standard related to heat detectors. The maximum detection radius for a heat detector is 4.5 meters. For a square detector array in an open area, the detectors should be within a maximum distance of 6.4 meters from each other. They can be no more than 3.2 meters from a wall or a large obstacle. In corridors, not exceeding 2 meters wide, attention should be paid only the points close to the center line of the corridor and if heat detectors are placed at 9 meter intervals. The distance wall should be maximum of 4.5 meter. If the protected area has a slope ceiling, for detectors at near the top, the horizontal distance given above may be increased by 1% for each degree of slope, up to a maximum of 25%. 6.5.4 is the standard related to the alarm buttons. Alarm buttons should be placed on escape routes, all interior and exterior doors of escape stairs, and all exits to open air. They can also be placed near special hazards and firefighting equipment. In situations where persons with limited mobility are incapacitated or require special care, the placement of alarm buttons may require additional care. Alarm buttons should be clearly visible, identifiable, and easily accessible. Special arrangements may be appropriate in areas where alarm buttons may be subject to reckless or malicious operation. Subject to the agreement of the appropriate implementing authority, in general, alarm buttons should be fixed at a height of 0.9 meter to 1.4 meter from the floor and comply with EN 5411. 6.6 our standard for alarm systems and devices. 6.6.1 is our general standard. In this standard, visual and tactile alarm devices should be used to supplement audible alarms in areas where audible alarms may be ineffective, for example, where background noise is excessive or hearing protection is likely. In areas likely to be used only by hearing impaired, procedures should be in place to inform them of alarm, or visual and tactile alarm devices should be used to supplement audible alarms. 6.6.2 is our standard for audible alarms. The sound level should not exceed 118 decibel at any point where people may be present. The fire alarm must continue for more than 30 seconds at least 65 decibel or 10 decibel above any noise, whichever is greater. If the alarm is intended to allow people sleeping, the minimum sound level at the head of the bed should be 75 decibel. These minimum levels must be reached at any point where the alarm should sound. 6.6.3 is the standard given in addition to the standard related to visual fire alarm devices. Visual fire devices must comply with EN 5423. Any visual fire alarm must be clearly visible and distinguishable from other visual signals used in the building. Visual alarm devices should be numbered and positioned so that they can be clearly seen from any point in the area in which they are used. In places that are likely to be used the hearing impaired, procedures should be applied to inform them about the alarm. And audible visual and tactile alarms devices should be used according to the space usage characteristics. As you can see, in case of alarm, warning is provided by the vibration of the pillow. As a result, fire detection and alarm systems are of critical importance for both life and property safety at the point of preventing possible fires in hotels. In addition, after the fire detection and alarm system installed in the hotels are installed, commissioning, testing, training, and acceptance processes, operation and maintenance processes must be carried out in the best and complete manner in order to keep them in working condition. EN 5414 is used as a standard in the world. Thank you very much for your participation, and don't forget to attend the webinar we will hold on Thursday next week.